So it just wants to know what R of t is. It just wants to know what's coming in. It doesn't want to know any, like, what the actual volume is. It just wants to know the rate at which it's coming in. So it's the integral from 0 to 8, because that's what it told us, of R of t times dt. And you can just plug this right into your calculator. Well, you'd plug in 20 sine of t squared over 35 to R of t, and you get 76.570. So for B, it asks, is the amount of water in the pipe increasing or decreasing at time equals 3 hours? Give your reason for your answer. So what you're doing is you want to know, because the water's coming in at a rate of RT and going out at a rate of DT. So you want to know if RT is greater or less than D of T. So you're going to do R of T minus D of T at T equals 3. So R of 3 minus D of 3. And then you're going to use the functions that you're given in the problem, and you plug in 3, and you get negative 0.3136. So the amount of water in the pipe is decreasing at t equals 3 because the amount of water is modeled by RT minus D of T, and D of T is greater than R of T, which means more water is coming out faster than it's coming in. So that's basically what B is asking for. It just wants to know if water's coming in faster or going out faster, and it's going out faster, so it's decreasing. Okay, for C, it says at what time t from 0 to 8 is the amount of water in the pipe a minimum? Justify your answer. So we know what R of t is, and we know what D of t is, so you can just plug it into your calculator. So you can see here that, so the blue one is R of t, the red one is D of t, and the black one is R of t minus D of t. So you can just plug those into your calculator and you will be able to see the different graphs. And so what it wants is, so what you're going to do is, here's the time, you're going to make a T-chart, and here's the volume, or the amount of water in the pipe. And so if you look at your graphing calculator, when R of t minus D of t is 0, is at t equals 3.27. So basically that means is that's when R of t becomes greater than D of t, so water is starting to come in faster than it's coming out. So you always want to check your endpoints just to make sure that they couldn't be your minimum. So at t, if you plug in 0 to R of t minus D of t, it is 30. And then if you plug in 3.27, you get 27.96. And then if you plug in 8, you get 48.54. So the amount of water in the pipe is at a minimum at t equals 3.27 hours. All right, so that's C, so now we just have D left. So D is asking, the pipe can hold 50 cubic feet of water before overflowing for T is greater than 8. Water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. So first of all, 50 is T of W. So it's the time at which W, the volume, will overflow. So 50 equals 30, because that's your initial amount, plus from 0 to W, because we don't know the time of T times dt. And so we bring this 30 to the other side, so 20 equals the integral from 0. So the integral is from 0 to W of T prime of T times dt. Or you can write it as 20 equals the integral from 0 to W of R of T minus D of T times dt, which is T prime of T. So now you can, if you have any more questions, you can go to this link right here, or you can just type in this, and it is just basically another way of explaining this problem if you need any more questions. Thank you.